Hey, how's everybody doing? Welcome back to Seneca Prep. I am Jono, and today I have the joyous task of talking you through Lewis diagrams for covalent structures. I love Lewis, I love a dot, I love a cross. It's going to be a journey. I'm excited. I hope you're excited. Let's go. You ready? Lewis diagrams. What are they? Lewis diagrams can be used to represent covalent bonds and to show the sharing of a pair of electrons. Sharing is caring, okay? I don't care what nobody says. I used to love the Care Bears. They shared all the time. Sharing is caring. That was their logo. Also applies to Lewis structures. Bam. Learning connection. So chlorine, Cl2. Each chlorine, Cl atom begins with 7 electrons in its outer shell. 7. By sharing one pair of electrons in a single covalent bond, each Cl atom attains a full outer shell with 8 electrons. We call that the octet rule. So we want to fill that octet. We want to have 8 electrons in that outer shell. So for chlorine to get that complete outer shell, it has to bond with one. It needs an extra electron. 7 plus 1 is 8. I'm not a mathematician, but I think that's right. So this is the octet rule. Atoms are going to bond together to fill that octet. Fill that octet. Now, let's go through water. So water has 6 electrons in its outer. So oxygen, part of water, has 6 electrons in its outer shell. We can find this out just by looking at a periodic table, and you see that oxygen is in group 6. So there's going to be 6 electrons in its outer shell. Bam. That means we need 2 more electrons for oxygen to get its full outer shell or its full octet. So to do this, oxygen forms a single covalent bond with 2 hydrogen atoms. It can't form a double bond with hydrogen atoms because hydrogen only has 1 electron in its outer shell. So it needs 1 more to fill its outer shell. The first electron shell can only have 2 electrons. So to get that full outer shell, you only need 2 for hydrogen. There you go. Hydrogen special. Let's also talk about double and triple bonds. So the earlier examples we went through, that was just single bonds, which is just one shared pair of electrons between atoms. But it is possible to form double and even triple covalent bonds. And double and triple bonds are normally larger and require more energy to break. So we'll go through an example. So oxygen, O2. Oxygen needs 2 electrons to get a full outer shell, right? We just said that it's got 6 electrons in its outer shell, so it needs 2 more. Therefore, each oxygen atom can share 2 electrons with the other and form a double covalent bond. So oxygen forms a double covalent bond. So each oxygen atom contributes 2 electrons to the covalent bond. And then we get a cute little double covalent bond. Hey! And oxygen has its full octet. Okay. CO2 also has a double bond. 2 bonds between each oxygen and carbon. And N2 nitrogen, that's got a triple bond. So that's a good one to remember. Often can come up as one of those like cute little multiple choice questions in the SAT, which is like, which of the following are like double bonded molecules? And then it's like CO2 double bond, bam. O2 double bond, bam. H2O, that's a single bond. Don't select that option. You'll get it wrong. And then you'll lose 0.25 of a mark because the SAT chemistry exam is mean and they negatively mark you. I'm over it. Types of covalent bond. Single, double, and triple. Single covalent bonds have 1 shared pair of electrons. So good thing to remember, group 7 elements. So that's the halogens. They all have 7 electrons in their outer shell. They need 1 more to get a full outer shell. So they form single bonds with each other. So like Cl2, F2, I2, they're diatomic. They go around in 2s. They like their full outer shell. Stability. We'll show you what that felt like. Double covalent bonds. This involves 2 shared pair of electrons. Can you notice a theme? Group 6 elements are joined by double bonds, so each atom needs to gain 2 electrons to obtain a full outer shell. Nice little rule to remember. So O2, S2, they're going to have nice little double bonds. Triple bonds, 3 shared pairs of electrons. So group 5 elements are joined by triple bonds, as each atom needs 3 electrons to gain a full outer shell. Handy rules to remember. Good. Make sure you practice drawing out these Lewis structures. That's the best way to consolidate what we're covering in this episode, okay? So draw them out, do a little pretty picture, like time yourself, try and do them as quick as you can. We love it. So nitrogen has 5 electrons in its outer shell. I've already hinted to the answer, so if you've been paying attention, you should be able to get this just right. So nitrogen has 5 electrons in its outer shell. What type of bonds form between 2 nitrogen atoms? So do the math. It's got 5 electrons in its outer shell. Needs 3 more. Boom, we got ourselves a triple bond. So nitrogen is a nice little triple bonded molecule. Something to remember. So Lewis diagram for hydrogen, H2. Each hydrogen atom needs to get 1 electron to get a full outer shell. Remember that the first electron shell can only hold 2 electrons, so we don't use the octet rule there. We just use the doublet rule. It might not be called the doublet rule. Don't quote me on that. Goodbye. Not quite yet though, because there's some more to cover. Each hydrogen atom shares 1 electron with the other, leaving 1 pair of electrons in the shared space between the atoms. So that's going to be a nice example of a single covalent bond. Single. So when carbon reacts with hydrogen to form methane, how many hydrogen atoms will bond to each carbon? So carbon has 4 electrons in its outer shell, and it reacts with hydrogen. Hydrogen has 1 electron in its outer shell. So how many bonds is carbon going to need to make with hydrogen? Well, I'm glad you asked. Remember that octet rule? Carbon is going to need 4 more electrons to get a full outer shell, so it's going to form 4 single bonds with hydrogen. And then you get CH4. Why does this happen? Well, let me break it down for you. Each hydrogen atom needs 1 extra electron shared with it to get a full outer shell. So each hydrogen atom is going to form a single covalent bond with the carbon by sharing 1 pair of electrons. Remember, covalent bond, shared pair of electrons. The carbon atom needs 4 extra electrons shared with it to obtain a full outer shell. So each carbon is going to form covalent bonds with 4 hydrogen atoms. Boom, boom. So another example would be HCl. That's going to be a single bond. Pretty like hydrogen, it likes its single bonds. Boom. So nice little fun fact. If you're drawing these little Lewis diagrams, you don't always have to draw the circle if you don't want to. I hate drawing circles, especially if I have to use a compass. That's the effort I don't want in my life. So you can just do it without the shells, yeah? So dots represent the outer shell of electrons of an atom of 1 element, and then you use crosses for the other one. So if we were drawing out NH3, lone pair of electrons, the dots you'd use to represent the electrons in N, and then the crosses is what you'd use to represent the electrons in H. So each covalent bond would be a dot and a cross. Dot and cross diagram, another name for Lewis structure. You're welcome. The more you know. So, Lewis diagrams for ammonia. When nitrogen reacts with hydrogen to form ammonia, how many hydrogen atoms will bond to each nitrogen atom? So nitrogen has 5 electrons in its outer shell. You should remember that from earlier. So it's going to need 3 electrons to get up to 8. So it's going to form 3 hydrogen bonds. And there's going to be a cute little lone pair there. So that's another nice example. And all of these compounds that we've been through, I would learn what they look like. Obviously, it's the SAT chemistry test. You're not going to have to draw Lewis diagrams, but they might, in terms of they're not going to mark you on them, but you might have to draw one to get to an answer. So it might ask you how many bonds would there be between nitrogen and hydrogen to form ammonia, something like that. And then you have to draw it out and be oh yeah, there's a lone pair of electrons, sick. So we love it. I don't know, that was a weird question. Anyway, this brings us to the end of this episode about Lewis structures, where we've been talking about how we can represent covalent bonds. I hope you've enjoyed the knowledge I have shared with you, like a pair of electrons. Bam, on fire today with the bad jokes. Keep up all your hard work and your studying, and make sure you check out the other episodes. Also, we're going to be building on the content covered in this episode when we talk about molecular shapes. What, you ready? And polarity as well. So there's loads to build on covalent bonds, you lucky thing. So stick around. Catch you in another episode. Any feedback on these would be sick. Make sure you subscribe and keep updated so you can see all the new content we're putting out for you guys. We want the best for your education. So enjoy these free resources. Boom. Catch you later on the next episode. Bye-bye.